Okay, guys, I'm hoping we are all back and ready. Cumber's come up with our first cow joke. Love it. Like I said, love a cow joke. So what we're going to do over this rest of this lesson and then Wednesday's lesson is just sort of like recap some important stuff that we need to know from grade 7. I sort of have like an exam here. We don't necessarily need to do all of it. I just over prepared. But we're going to look at the really important concepts that we need to know to start off with, which is going to be from about question 2. We'll come back to ones as we go along, but basically we're just going to have a look at some of the important things that we need to know heading into grade 8. With that being said, a lot of the stuff that we're going to chat about now, we're going to chat about again as we go through like the grade 8 work. So don't stress if you're feeling a little bit uncertain or a little bit unsure. We're going to chat about a lot of this stuff again. So don't feel overwhelmed. We're going to do it again and again. We're going to have lots of practice. But that is sort of the plan for this week. And then as of next week, we're going to start with our first grade 8 section, which is going to be talking about whole numbers and like working with whole numbers and what they are and how we use them, etc., etc. So just that you know what's coming up. So yeah, let's jump straight into it. So we're going to start, like I say, with question 2, because this is sort of leading us into our very first section that we're going to chat about as of next week. So the first question here is asking us which value is bigger, 1/2 or 2/3. Now, there's lots of different ways you could go about this. You could draw a picture for yourself. You could do it more mathematically. So we sort of need to, and you need to decide how you're more comfortable with these sorts of things. So if we imagine what each of these represents, so if we think of it in terms of like a picture, I'm going to see if this works. I'm not holding a lot of hope here, but we'll see. So if we think about a half visually looks like that. If we then think about 2/3, I could draw very much a similar sort of picture. Oh no, that wasn't great. Let me try that again. Draw a very similar picture, but now we can split our circle into thirds. And so 2/3 would be 2 parts of that whole. Now, as Karabo said in the chat, 2/3, if we look at it, is bigger. It's more of the pie, all right? Now, sometimes, I mean, like sometimes the fractions we work with, we can't draw nice, pretty pictures and like just draw a picture and figure out what the answer is. Excuse me. So we need to have another way of figuring out which of these values is bigger. And in order to do that, what we do is we go and use some maths, right? This is why we're here. And so if we go and look at these two numbers, basically what we want to do is we want to try and make them comparable. My pen's just fighting with me today. And the way we make fractions comparable, the way we are able to compare fractions that look a little bit different, is we look for what we call a common denominator. Now, some of you would have heard the term LCD. We're just going to fight with this thing. But essentially what we're wanting to do is make those denominators the same so that if we were to draw a picture, we've got the same parts of the pie or same number of pie pieces that we can then compare. So my next question to you guys is, firstly, if we look at the two denominators, now remember denominators are the numbers at the bottom of my fraction. I want to know what is the smallest number 2 and 3 can divide into. So what is the smallest number that both 2 and 3 can divide into? So, oh, sorry guys, my chat's just gone haywire and I'm seeing lots of great answers. Oratilwe has already put an answer there. We've got 6, we've got lots of 6s. If you're struggling to figure out what that is or how to work that out, one way we can do it is we can look at our times tables. So the 2 times tables and the 3 times tables. If we look at our 2 times tables, I'm not going to do all of it. We've got 2, 4, 6, 8, and so it keeps going. If we look at our 3 times tables, we've got 3, 6, 9, and so it keeps going. The smallest one, or the first number that appears in both times tables, is 6. And so what's happening here is we're saying that 6 is the smallest common number between 2 and 3. And this is what we call, again, a common denominator, or specifically a lowest common denominator. And so now what I can do is I can say, okay, cool, I know what the common denominator is. Let's make both of these denominators 6. So if I look at the denominator of 2, if I times 2 by 3, don't know why it's not working, but we're just going to roll with it. Sorry. If we times 2 by 3, we can make that 6. So if I say, it's going to fight with me today. If I times that by 3, it'll become 6. So we'll have a denominator of 6. And if I times the 3 by 2, that will become a denominator of 6. But what we need to remember is that whenever we work with fractions and we change the denominator, we need to multiply the numerator by the same thing. So 1 times 3 is 3 over 6, and 2 times 2 is 4 over 6. And so what we've done here is we've taken our LCD and made these denominators the same. Because what that now means is I can go and compare this, or compare these two fractions a little bit easily. More easier? I don't know. Anyways, so if we now were to go and draw a picture, so I'm going to take these beautiful pies off and we're going to draw a picture of what we've just done here. If I now go and draw a picture of these pies with 6 parts each, I've made that too big, but anyways, there's a pie with 6 parts, and the first fraction that we had is 3 over 6. So there are my 3 pie pieces. The next fraction that we had also out of 6 was 4 out of 6. And so if we color in our pie pieces, we've now got 4 pieces colored in. And so by making the denominators the same, what we've done is we've created a situation where the parts of the whole are exactly the same. And we can now go and compare. So I'm going to ask you guys again, if you go now and look at these new pie pieces that I've drawn, which one is bigger? So this first one, remember, was 3 over 6. This one. Today, we're just going to deal with some technical issues clearly. So this first one is 3 over 6. The second one is 4 over 6. Which one is bigger? 4 over 6 or 3 over 6? Which one represents more? Would you rather have 4 out of 6 pieces of pizza, or would you rather have 3 out of 6 pieces of pizza? Okay, I'm seeing a couple 4 over 6s come through. That's how I sometimes like to think of fractions, is it's a pizza. If I get 3 pieces out of 6 pieces or 4 pieces out of 6 pieces, which one do I actually want? I want more pieces. So I want the one that gives me more pieces of pizza, or more pieces of the pie, or whatever you want to imagine this is. So if we look here, we can see that this represents more because I get more pieces of the whole than I do from the 3 out of 6. Now this 4 out of 6 that we got came from, that's a terrible color to use, I made some weird choices there. This 4 out of 6 that we got came from the 2 over 3, because remember we multiplied to get the denominators the same. And so when we now want to ask ourselves which is bigger, we can now say 2 over 3 is bigger. Now again, fractions is I don't want to say is a hard section, but fractions is a very, very important concept to understand in maths, because you're going to use fractions across the board. You're going to use it up until matric. And these concepts of being able to compare fractions, being able to create the same denominators, everything that we've done here is going to be important all the way up till matric. Now, again, don't stress if this is a bit overwhelming. We're going to do a whole course on fractions. So we're going to chat about this at length. So don't worry, this is more just to remind you what fractions are, how we can work with fractions, and just hopefully, what's the word? I don't know, rekindle some of the knowledge that you have somewhere in the back of your head. Now, some of you might have done this a bit differently. That's absolutely fine. I'm never going to tell you have to do it this way. You have to find what works for you. But what we've seen here is that to compare these fractions, we made the denominators the same so that we could do that. Right, Tammy, do you have a question for us? Tammy, you there?
You just need to sort of click on a button that comes in your screen. There we go. Oh, okay. Let's try that again, Tammy. There we go.
Can you even screenshot?
Sorry, Tammy?
Can you even screenshot?
Do you want to screenshot this?
Yeah.
Okay, so what I'll do is I'll make it a bit smaller so you can see everything. You will have to figure out how you screenshot on your device. It's going to depend on what you're using. I can't really help you too much, but if you've got a laptop, if you push the print screen button, you can essentially copy the screen. You just then have to paste it into like a Word document or something. Yeah. Otherwise, take a photo of it. But there you go. If you guys want to take a screenshot, you are welcome to do that now.
Thank you.
Okay, so guys, what I'll always try and do is sort of show you the whole answer or the whole question or whatever with all of the working out, so that if you do want to take a screenshot, you can. And I generally will try and wait a couple seconds before I move on to the next question so that you can get a screenshot. But obviously, if I don't, just say so and I'll go back to where we need to take screenshots. Okay, let's have a look at 2.2. So 2.2, I've now given you like a whole list of numbers. You've got 21, 36, 111, 3/4, 19, 12, and 4/3, or 4/3. And so from this list of numbers, we now need to identify a specific type of numbers. So the first one is asking us to identify from this list of numbers a prime number. So let's take a second. What is a prime number? Can someone tell me in the chat, or does someone want to raise their hand? What is a prime number? Tawanashe?
Hi, ma'am. To my understanding, a prime number is a whole number greater than 1 that can be divided by any whole number other than 1 in itself.
Okay, perfect. That was a beautiful, beautiful explanation. Well done. So basically a prime number, guys, is a number greater than 1, which we're going to talk about whole numbers and all of that in our next course, but is a number that can only be divided by 1 in itself. It only has 2 factors. So just to sort of explain this a little bit further, and I can see some of you already putting answers in the chat, that's absolutely fine. If we think about the number 4, okay, if we think about the factors of 4, or the numbers that I can multiply together to get 4, I know that I can multiply together 1 and 4, and I can multiply together 2 and 2. Now, the fact that there's more factors than just 1 and 4 means that this is not a prime number. But if we think about the number 3, the only way I can get 3 when multiplying numbers is to say 1 times 3. There's no other pair of numbers that I can multiply together to get 3. And so that means that that is a prime number. And that is essentially what prime numbers are. So now we want to look at this list of numbers and decide which of those are prime numbers. And I can already see quite a few on the chat. Most of you have said it. 19 is our prime number in this list here. Let's see if this is going to let me write. We're getting there slowly but surely. Right, 19. That is our prime number from the list. The only way I can get 19 is if I say 1 and 19. There's no other pair of numbers that I can multiply together to get 19. Sometimes we sort of automatically go to the odd numbers. So for example, like 21. But 21 isn't a prime number because I can get 21 by saying 1 times 21, but I can also get 21 by saying 3 times 7. And the fact that there is that other pair means it's not a prime number. Fatima put it on the chat as well. These numbers, so like the number 4, that have multiple factors more than 1 in itself, are what we call composite numbers. And you don't have to know that right now. We're going to talk about this in our next course, so we're going to chat about this again. But there is a name for numbers that are not prime numbers. They are called composite numbers. Right, very nice, guys. So we've got 19 as our prime number. So the next one is asking us to go and find a number that is an improper fraction. So does someone want to explain? You can put your hand up, you can put in the chat, what is an improper fraction? Like, how do we identify improper fractions? Right, Rolivua, tell me, what is an improper fraction?
Is it
Am I saying
when
your name correctly? Sorry.
Yeah, it's Rolivua.
Rolivua. Okay, thank you.
Yes.
It's when?
Is it when the numerator is bigger than the denominator?
Excellent. Well done. So guys, improper fraction is when the numerator or the number at the top is bigger than the denominator or the number at the bottom. So essentially improper fractions actually represent a whole and then a little bit extra, or multiple wholes and then a little bit extra. So a lot of you have put in the chat that it would be 4/3, which is excellent because as Rolivua has told us, it is the numerator is bigger than the denominator. And so here our improper fraction is 4/3. And what this actually means, if I try and draw a beautiful diagram for you again, if we were to sort of, let me get my words correct. If we wanted to convert this, now we're going to talk about this also, don't stress. If we wanted to write this as a mixed number, so a whole number and then a fraction, this could be written as 1 and, oh, guys, me and technology, today we're going to fight. 1 and 1/3, okay, which means that it is a whole. I'm clearly not an artist. And then 1/3 of the next whole. And so improper fractions often represent to us more than a whole. Okay, excellent. I'm hoping we're all happy that 4/3 is an improper fraction. And I'm hoping that we're all happy that the 3/4 is not an improper fraction. It is not where the numerator is bigger than the denominator, so that is not an improper fraction for us. Okay. So the next question, whoopsie daisies, is asking us to look at the two fractions that we do have, so the 3/4 and the 4/3, and decide what is the smallest common denominator of those two fractions. Now, this is linking back up to what we spoke about here. What is the smallest number that both 4 and 3 can divide into? You guys are on it tonight. Right, so exactly, the smallest common denominator here is 12. Now, again, the reason that we often work with common denominators is because this is the way that we can compare and do operations with fractions. You're going to see when we eventually do our fraction section, when we want to add and subtract fractions, we have to have a common denominator. We have to make them somewhat similar in order for us to work with them. And so being able to find this common denominator is super, super important, and you guys are clearly on it. So our smallest common denominator, or you can call it the lowest common denominator, in this case would be 12. Why? Just to remind you, because 12 is the smallest number that 4 and 3 can divide into. Again, if you wanted to, you could go and list for yourself the multiples of that. So 4 we know is 4, 8, 12, and then 16, and so on. If we list the multiples of 3, 6, 9, 12, and what we see there is that 12 is the smallest common one between both of those. Hence, it is our smallest common denominator. Right, very nice, guys. Rolivua, I see your hand still up. Do you have a question for us?
Oh no, sorry, I'll put it down right now.
No, don't stress. Okay, guys. So let's have a look at our last one. We've got time for our last one. So 2.2.4 is asking us, let's pick a new color. Let's go purple. You guys are really on it. I haven't even said the question. It is saying that the numbers 1, 2, 3, 4, 6, 9, 12, and 18 are factors of. Okay, so a lot of you have already put an answer in. Absolutely fine. My first question, though, is what are factors? So you can raise your hand, you can put in the chat. what are factors? Like what does that mean? And we have sort of spoken about it a little bit, but what are factors? Anyone? What are factors, guys? Tawanashe? Oh gosh, my tongue didn't get like the words out. Tawanashe?
Hi, ma'am. So what my teacher told me is a factor is a number that divides another number evenly with no remainder.
Perfect. Okay, awesome. And I see a couple of you put that in the chat as well, something very similar. So factors are basically numbers that can divide into another number without a remainder. Now, if we go back to what we were speaking about here with our prime numbers, these are factors. So these things here, oh, that was very aggressive. I do apologize. We didn't need something so aggressive. These are factors. Okay, they are numbers that when I multiply together give me a specific value. So I want to say 36, but you are correct to say 36, but we'll chat about that in a second. So if we think about these factors that we have been given here, now, I mean, you can really think of it in any way you want, but you sort of want to ask yourself, of all of these numbers, what number can all of them divide into without a remainder? Now, and I don't know why I'm saying I want to say 36. 36 is correct. Clearly, my mind is now tired. If we go and have a look at our factors, we've got 1, 2, 3, 4, 6, 9, 12, and 18. So all of those numbers have to divide into a number. Now, a lot of you say 36, so let's chat about this. 1 can divide into 36. 36 divided by 1 is 36. 2 can divide into 36. 36 divided by 2 is 18. 3 can divide into 36. 4 can divide into 36. And all of these numbers can divide into 36 without a remainder. That's very important. Okay. And so if we want to go and say what number are all of these numbers factors of, we can say 36. Now, if we think about this in terms of factor pairs of which numbers go together, we know that 2 times 18 is 36. We know that, oh, I haven't put all of the factors yet. We know that 3 times 12 is 36. And so we're starting to see that these are our factors of 36. There's many more. There's 8. There's, I feel like I'm missing another one. Oh, 6, obviously. All of these numbers can divide into 36 without a remainder. And that's what factors are. Alrighty, so we have covered basics of fractions in this first question 2.1. Give up. We've covered what prime numbers are. Now, again, we're going to chat about those again. We've spoken a little bit more about fractions, and we're going to do a whole course on fractions. And we've spoken about factors, a lesson that we're also going to have in terms of what are factors and what are multiples. So a lot of what we've covered here are really the important foundation stuff that we're going to build on as we go into grade 8 and sort of the rest of high school. We're going to carry on with sort of revision questions on Wednesday, so do not stress. We're going to have a look at more like solving some equations, simplifying expressions, that sort of like really important stuff, but that will happen on Wednesday. But you guys were amazing. Thank you so much for being here. And I am very much looking forward to hopefully the whole year with you guys. Yolanda, anything you want to add?
No. Thank you so much, everyone. I think I dozed off. Thank you, everyone. Y'all are amazing people. And thank you so much, Teacher Sam. And yeah, we'll see you on Wednesday.
Well, I'm sorry, just Tawanasha, I see your question in the chat. So a lot of basically from what we start from next week in terms of our courses, that will be your grade 8 content. So that's what you will be doing in high school. Some schools do things a little bit differently. So you might be doing things a little bit differently at your school, but that's absolutely fine. Basically, everything that we do as of next week will be what you're doing in high school and what you're doing in grade 8. Okay, so.
And just as a quick reminder before we close up, guys, remember we record everything. So that's the best thing about us, that you will always go back and just watch the recording again to help you, you know? So yeah. Thank you, everyone.
Have a wonderful evening, guys. We will see you on Wednesday.